gives you a diagram showing two parallel plates. They're separated 10 centimeters apart, the plates are. Calculate the voltage in between points 1 and 2. And those points are 4 centimeters apart. So those points aren't necessarily a charge. We're just saying voltage changes as you go down. So how much voltage is in between at that location? So what we're going to do is we're going to be using our electric field strength formula, but we make the assumption that since we're not changing like the battery, like we're not putting a new battery or anything, that the electric field strength stays the same. Okay? The electric field strength stays the same. So we write that in. Electric field strength remains the same. Electric field strength remains same or uniform, but the voltage, okay, is what changes in between. So it's changing as I go between the plates. I'm not saying that I'm changing this voltage. This is like remaining the same, but I want to see how much voltage I have once I get to this point. Okay? Because between here and here, this whole big gap, there's 1.2 times 10 to the 3. But what about when I get into the middle? Okay? So just kind of keep that whole thing in perspective. So what we're going to do is we're going to look at between plates, okay? And then we're going to look at within plates. And that's talking about point 1 to 2, okay? This is between like the whole plates. So we are told the distance here, okay? So we're told distance is equal to 0.10 meters. Convert those centimeters into meters, okay? And then we are also told the voltage, 1.2 times 10 to the power of 3 volts. Now here, we are told the distance that we're looking at within the plate, so I'm going to call this D2, is 0.04 meters. And what I'm looking for is the delta V in between these 2 points at that spot. That's what I'm looking for. So we said that E with the arrow, our uniform, our electric field strength, stays the same regardless. So what can I do here and kind of transfer over? What stays true for both? My E, okay? So we have our E equals delta V over D. So it's like I can solve for this electric field strength and say it's true for both sides, okay? Kind of, it's like almost like a stoichiometric type of question, right? You can apply one thing, one variable to both sides as being true, okay? So our electric field strength for this is our delta V over D, or delta D, 1.2 times 10 to the power of 3 volts divided by 0.1 meters. So our electric field strength is 12000 Newton coulombs. So now I'm gonna take this value and then I apply it to this side. So my E is equal to 120, 123 Newton coulombs. I'm looking for delta V. So I'm gonna rearrange, so delta V2 is equal to E times by D2. So we have 120 Newton coulombs times by 0.04 meters.
Is it 4 zeros or 3?
Oh, it should be 3, sorry, I put 4 on this side, thanks. 1, 2, 3, yep. So this is 480